volume is space occupied by a solid object. For example, when we have a cylinder, so the space occupied by a solid object, so it's going to be, this is the height and this is the radius of the cylinder, then the volume of the cylinder is going to be pi r square h. So volume is space occupied by a solid object. But this shaded area is not a solid object, it's a flat object. Then what happens? How do we find the volume when we have something that is a flat object? Obviously, so what we do a revolution. We rotate this around the x-axis, the entire shape, so that it turns out into some sort of a solid. So the solid solid that we find, this shape, when we rotate this around the x-axis, that shape is going to give us a solid after we rotate it, and we are finding the volume of that solid. So how do we find the volume of that solid? What we do here is we slice it up into small discs. So that's what we do. So what we do, we slice it up into small discs like this, and we take many discs from here and we add up the slices just like we add up the areas. We add up the slices, and the slices are, if we add up the slices, it's pi r square. Now the radius is y. This is the radius, so y square, and dx is a small portion of the disk. So if this is the slice, then this portion, that would be dx. So this would be pi y square dx, and the limit would be starting from a to b. So it could be shown here in, so if this is the region, and if we rotate it, it becomes a solid. Becomes a solid like that. And then when we want to find the volume of this solid, we break it down into small slices. So one slice is like a disc, and when we take this particular disc, this is the height of the cylinder, and we finally, when we want to find this, what we do is find pi y squared dx. So that is going to give the volume of the cylindrical shape that we have over here. So when we want to find the volume, it is going to be the limit pi y squared dx, and it is always a solid, and we call it solid of revolution. Now if you have a region like this, which is a bit more complicated, we have a line here and we have a curve here, and the region that we want to rotate is this one. So what would this look like? So if we had the line only like this, and if we rotate it, it would look like a cone. So this is another line, y equals to 3x. You can see that how this rotates as we take this line and rotate on the x-axis. It traces out a shape, and the shape is like a cone. So that's how the 2D shaded region is converted into a 3D solid. And if we take this curve over here, and if we rotate it, it would look like a different sort of a cone, a bit squeezed here over here. But when we take this region and we rotate it, so what it would look like, it would look like some sort of a cup where this is empty and we'll get this. So something like this. So this is the cup. This is empty here over here. So this outer covering, that is the full cone, and this inner covering is made by the curve. So this is, if you take a look over here, so it's like this, some sort of a cup.